Good morning to all. This class we will discuss about what are the terminologies used in metrology. First we discuss what is accuracy. Accuracy is defined as the closeness of agreement between a test results and the accepted reference value. Accurate instrument would provide measurements closest to that actual value or standard. It's based on how the instrument is working. We get that good accurate results. Next we discuss what is precision. In precision, how close one measurement result will be to the another result or set of results. The ability of a device to provide with the consecutive measurements that are close to one another. The term precision is often used as a synonym for an instrument's repeatability. So number of times you have to take measurements of one component, how the instruments perform, based on we get that precise value of particular things. Differentiate accuracy and precision. In accuracy, which is the result of a measurement conforms to the correct value or a standard value. In precision, the quality of being exact and refers to how close two or more measurements are to each other. So, number of times you have to take and you have to check whether that instrument given that accurate and precise value. Both accuracy and precision reflect how close a measurement is to an actual value, but they are not the same. Accuracy reflects how close a measurement is to a known or accepted value, but the precision reflects how reproducible measurements are, even if they are far from that accepted value. How much variation, how much deviations it will become from that accepted value. So measurements that are both precise and accurate or repeatable are very close to true values. Next, we will discuss what is calibration. Calibration is the process by which a measurement device is checked for accuracy against a known standard value. Set of operation that establish the relationship between values indicated by instruments and the corresponding values given by standards at a specified conditions. So you have to check that instrument under that calibration process, then only we get that precise and accurate value of the particular component. Next we discuss readability and resolution. Readability refers to the ease with which the readings of measuring instruments can be read. So here given that two images, vernier and micrometer, so easy to understand which one is can read easily. Then resolution. In resolution, the smallest change of the measured quantity. If any variations or deviations occur during that process, immediately have to reflect. So with changes, that indication of a measuring instrument is called resolutions. Repeatability is defined as the closeness to which a measurement taken from that instrument to give that same value when multiple measurements are collected. So you have to confirm whether that instrument perform, and also to taken the readings to take average and you have to use it. It does not take into account measurement of different components, not different objects. You have to use same component instruments, then you have to check whether that repeatability it will become under that specified conditions. In magnification, output result from a measuring device to be magnified many times to make it more readable. So it will be help to interpret that measured value or results. Next, measurement traceability. Measurement traceability is also known as metrological traceability. This is simply how metrologists connect to the standard by which they measure. So the experimenter or metrologist, when you have to conduct that experiment, so how it will be connect to that standard value. So this deals with measurement traceability. Sensitivity is defined as the rate of displacement of the indicating device of an instrument with respect to measured quantity. How that instruments perform during that process. So based on that, the sensitivity is defined. Ratio of the scale spacing to the scale division value. It's also known as sensitivity. Next, what is the range in measure of the instrument between the lowest and highest readings it can measure. So what type of values available of that particular instruments, lowest to highest, is called as a range. Next, error in measurement. Measurement error is defined as the difference between the true or actual and that measure value. So it's classified into two types of errors: systematic error and random error. Systematic errors are errors that are not determined by chance but are introduced by an inaccuracy. So you have to easily to find out to take that value with the support of instruments. We not get that accurate value. So based on you have to find out that systematic errors involving either that observation or measurement process to the system. Systematic error can be determined and reduced if attempts are made to analyze them. Systematic errors are calibration, ambient conditions, stylus pressure, parallax error, and misalignment error. So these are that possible errors occur that during the process. Another type of error, random error. Random error are not repetitive and they occur randomly. It is caused by inherently unpredictable fluctuations in the readings of a measurement apparatus or in the experimenter's interpretation of the instrument reading. It cannot be analyzed properly. So the random error occur during the process. So based on the experimenter's interpretation, sometimes the experimenters not have good perform to conduct the experiment, or any fluctuations possible during that process. This is that main causes of that random.
Thank you.